Pull the valve cover on this engine. Look at the metal surfaces on the camshaft lobes, the rocker arms, the lifters. There's a dark, almost mirror-smooth film across every friction surface that shouldn't be there after 230,000 miles. The metal looks like it came out of a machine shop this morning. That film is molybdenum disulfide, a $2 bag of dark gray powder you can order from any industrial supplier or find in the lubricants aisle if you know what to look for. 1 pinch per oil change. That's it. And the wear patterns that should have retired this engine years ago simply aren't there. I'm not going to tell you this is a new discovery. It isn't. NASA was running MOS2, molybdenum disulfide, on Space Shuttle mechanical systems as early as the 1970s. It was in the joint actuators, the deployment mechanisms, anywhere metal moved against metal in a vacuum, where conventional oil would evaporate instantly. Before that, World War II industrial engineers were using it on military vehicle transmissions and artillery mechanisms, because it held up under conditions that destroyed conventional grease. And before any of that, miners pulling molybdenite ore out of the ground in the early 1800s noticed it left their tools with an unusual, almost frictionless quality wherever it made contact. In 1822, a Swedish chemist named Jöns Jakob Berzelius analyzed the compound formally and confirmed what mechanics had known by feel for decades. The same compound, found independently in mines, military depots, and spacecraft assembly floors across 2 centuries. That kind of convergence doesn't happen by accident. That's physics being obvious to anyone paying close enough attention. You already know this reaction. You've seen it your whole life and just never had a name for it. That pencil mark you made as a kid that made a sticking zipper slide easier. The graphite a locksmith sprays into a door mechanism before he touches anything else. The slick, dark smear on your hands when you handle certain industrial components. All of it is the same family of chemistry. Layered hexagonal crystal structures that slide against each other with almost no resistance. When the powder enters your engine's oil, heat and pressure drive the molecules into the microscopic valleys and scratches in your metal surfaces. They don't coat the metal, they bond into it. Think of it less like painting a surface and more like filling the valleys in a mountain range until the terrain becomes flat. Once those surfaces are filled, metal doesn't contact metal the same way anymore. The friction points that eat your engine aren't making the same kind of contact. The wear rate drops, sometimes dramatically. The reason you've never heard of it is honestly kind of annoying. The global automotive parts and repair industry generates over $300 billion a year. A meaningful slice of that comes from engine wear, oil consumption, piston ring replacements, bearing work, and eventually the rebuild or replacement that comes from years of friction doing exactly what friction does. A $2 powder is not a business model. It's a business disruption. The commercial versions of this compound, the branded friction modifiers, the premium oil additives that list MOS2 somewhere in the fine print, run $15 to $40 a bottle at your auto parts store. Same chemistry, different packaging, 10 to 20 times the price. So let me just show you how to do it. Here's the parts list, and I want to be real with you. This is genuinely it. Molybdenum disulfide powder, technical grade, at least 99% purity. You're looking for a particle size of 1 to 6 microns. That's the spec that actually gets into the friction surfaces. You'll find it on industrial supply sites, it's on Amazon, and most lubricant suppliers carry it, for about $8 to $12 for a 100-gram container. That's enough for roughly 50 oil changes, which brings the per treatment cost to about 20 cents. That's the whole list, one item. At your next oil change, after you've drained the old oil and installed a fresh filter, add your new oil normally. Then measure out roughly a 1/4 teaspoon of the powder per quart of oil your engine takes. For most 4-cylinder engines, that's about 1 level teaspoon total. A 6-cylinder or V8 gets a bit more, a teaspoon and a half. You're targeting a ratio of 0.25 to 0.5% of total oil volume. Drop the powder in and let the engine idle for 10 minutes before you drive it. During that idle, you might notice something. The engine note changes slightly, a small reduction in the high-frequency texture of the idle. That's the powder distributing and beginning to work its way into the surfaces. Not dramatic, but it's real. Here's the one thing people get wrong when they first try this. They add too much. More is not better with MOS2. At concentrations above about 1%, the excess powder doesn't bond, it just circulates. And in high concentration, it can affect oil flow through the narrow passages in modern variable valve timing systems. My first test was on a 2003 Toyota Camry with 185,000 miles that had developed a dry, slightly metallic clatter at cold starts, the kind of noise that makes you wince every winter morning. After 2 oil changes with the powder, the cold start clatter was gone, which sounds modest until you consider what that noise actually represents. Metal-on-metal contact during the 3 to 5 seconds before oil fully pressurizes. The fleet operators who began documenting MOS-2 in their maintenance logs in the 1980s weren't reporting dramatic before and after moments. They were reporting mileage. Engines that consistently reached 400,000 to 500,000 miles without bearing replacement or internal work. At the industrial scale, mining equipment, hydraulic systems, power plant machinery, engineering teams have documented surface wear reductions of 30 to 50%. Your car isn't a mining excavator, but the physics is identical. And I want to be real with you. MOS2 dramatically reduces surface wear. In environments with unusually high chloride exposure, coastal areas with heavy salt air, or regions with aggressive road salt, the bonded film will degrade faster. And this matters. MOS-Trin 2 is not a repair compound. If your engine already has scored cylinder walls, worn bearings, this powder will slow the progression, but it won't reverse damage. Think of it as maintenance, not medicine. Start it early, use it consistently, and it pays back in mileage. Start it after the damage is done and you're buying time. Here's the part that keeps sitting with me. The miners, early 1800s. The mechanics, 1940s. NASA, 1970s. 3 separate discoveries all arriving at the same compound. And somewhere in the decades between then and now, this knowledge just quietly sat on a shelf and gathered dust. 20 cents per oil change. And that knowledge is back in your hands. I don't know what brought you here. Maybe you just like knowing how things actually work. Doesn't matter. It works either way. Now you know how. Knowledge like this doesn't disappear on its own. It gets buried. This channel digs it back up. Subscribe if that matters to you. Take care, and I'll see you in the next.